All right, question number 8. Ooh, what do we do here? Is it a use substitution? No, not a use substitution. We're going to have to use a little bit of integration by parts here. So let me look at the integral first, right? X e to the 4x, right? This is a good candidate for column integration, if you're a fan of that. If not, let's make u equal to x and dv equal to e to the 4x dx. So this means that du is just going to be dx, and this means that v is going to be 1/4 e to the 4x. If you're unsure why, go watch the second video in which I explain this thing right here. By this thing right here, because you cannot see what my eyes are looking at the screen. I meant this thing right here. I should be more careful with pronouns. So in here, we would do a little bit of integration by parts. So we're going to get this is going to be x times 1/4, so 1/4 x e to the 4x minus the antiderivative of v du. So I'm going to pull that 1/4 out and just get an e to the 4x dx. This is going to be a sweet little integral over here. So we're going to get e to the 4x is just 1/4 e to the 4x plus a constant, which we're not going to care about in a moment. So our antiderivative is going to be equal to 1/4 x e to the 4x minus 1/16 e to the 4x. So when we think about our antiderivative now, same thing, we have a limit as r approaches infinity of what we just of this thing here, 0 to r x e to the 4x dx. We found that antiderivative, so this is going to be the limit as r approaches infinity of what we just found. I could pull out a 1/4, I could pull out a 1/16, but I don't really care at this point. We have this. So when we take our antiderivative, we're going to get 1/4 r e to the 4r. So right off the bat, like that thing's going to go off towards infinity. Like, let's not even waste our time. Minus 1/16 e to the 4r. And then we're going to take away, I'm going to just do it down here, 1/4 times 0 e to the 0 minus 1/16 e to the 0. Right, so when we take this limit, as r goes off towards infinity, this thing is infinite because of that 4 to the r, right? We're getting something infinitely large. And this r is also getting infinitely large. This thing is getting infinitely large. Just don't be careful. Like, don't say, well, this thing is going off towards infinity. This thing is also going off towards infinity. So I guess infinity minus infinity is 0. Like, that is just so not how infinities work. Like, basically don't treat infinity like a number. So because we got to infinity, our integral will diverge.